Understanding the idea of self-driving can be difficult to one because of all the opportunities it displays, such as LiDAR, person-to-everything, and partial automation. As if I talk about all of them, this video will be really long. But to truly understand what self-driving is trying to say to us, we must break it down step by step to fully grasp what self-driving actually is. Now, if we take a look at the video up here, we can see that it is driving itself without anyone controlling it. This is because of the robot utilizing infrared sensors that are connected to the main motherboard on the robot, which is sending messages to all parts of the robot to commit an action to ensure the robot doesn't crash into anything. Now, let's take a deeper look into each one of the pieces that are allowing the robot to operate by itself. Taking a look at the main Arduino control board, we can see that it has the most connections to wires and openings because everything in the robot has some sort of wire connection to it. This motherboard is placed in the center of the robot as it is the most prevalent part that is being used the most compared to anything else. If there is an error in the code, you can click the red button in the top right corner and you won't lose any progress because everything is saved within the coding app, as you would have to just refresh the code. As we can see in the image, it is showing the different sections labeled A1, A2, and A3. This means what motor is going to be connected to what. As if the circuit board allows the battery to be connected with the camera, that wouldn't make any sense, which is just a waste in the spot in the board, as this could be applied for something like connecting the motor with a LiDAR camera, which is crucial for the robot. The L298N driver board is mandatory in the Arduino self-driving robot, as this is a main connector for all the motors to get power to actually run. In the areas that are circled red, you can see within the blue quadrants, we notice that there is a hole there, and the yellow motors that I will talk later about in the video are connected to wires to where these are put into the blue openings. The out1 and out2 are where you connect the motors A, as it is crucial to make sure that each motor is kept in the proper hole, or this can cause a glitch in the wheels doing the complete opposite of what you're asking it to do. The out3 and 4 on the other hand are motor B, as this is for the other side of the motors to function all four wheels of the car to make sure it moves efficiently without any errors occurring. And 1, 2, 3, and 4 are controlled to make sure the motor speed is at an appropriate level for the car to use its sensors to detect obstacles around it. The PWM, which is the pulse, is on both sides of where the black pins occur, which are located beside the blue quadrants. These are applied for sending signals to both motors A and B, so they are knowledgeable of the fact to move and stop at what specific times. The L298N motor driver board is located beside the main Arduino motherboard, as this is the driver board that has all the motors connecting to it, which is why it is convenient for it to be near all of the motors. This tool here is used to capture images from the image sensor, which helps navigate the car to avoid all obstacles within its path. The sensor shield also helps the Arduino board connect to the motors, as it gives it a cable connection from both by plugging one into one another. The shield can help customers avoid wiring issues and power pin shortages, which can often occur with the Uno and Mega boards, especially within the Arduino kit, as this seems to be a challenge for every user, which makes them struggle, including me. This shield gives a direct vision for the sensors, as it gives it a clear power and stabilization on what to actually look at. Without the shield, it would be looking in random directions, which would cause the robot to hit objects, causing damage. The URF01 and the SD Plus provide the camera with wiring options to plug into, as this can provide the camera with clear displays if they are plugged in correctly. This piece is directly attached on top of the main Arduino board, as this is because the wires don't have the compatibility to provide object detection recordings on the shield straight to the main control board. The HW096A tracking line obstacle avoidance sensor allows the robot to avoid all obstacles in track lines because the camera sends it information about its surroundings and then transports this info to the motors so that the RC car can actually avoid it. This tool provides the camera with LED sensors so they can easily tell the distance between the car and the object by using heat maps in their actual brain, but we don't have actual view on this, just like how a typical car would. The sensor can detect transitions from light to dark, which indicates a line or objects being directly placed in front of it. Because the avoidance sensor can't plug every wire into it, this means it must connect to the Arduino Uno board, which can handle everything, as this is the main board where the whole robot can be reset. The reason why it can't be connected to everything is because of the amount of pins it actually has to connect with everything. This is a small chip, so it must be placed accurately. The main connection between this sensor and the Arduino Uno main console is from out 1, 2, and 3. As this is a wired connection giving access to the Arduino board for camera awareness. This piece is located near the front of the robot where the camera is because of the placement having a nice and easy connection with also being able to connect with the Arduino board. Wires like this are abundantly convenient because these wires can easily be placed facing the roof so it doesn't mess with any of the batteries or circuits within the vehicle. These wires in particular are necessary because they all have different heads and tips, meaning that they all serve a different role according to the section it is specifically in. To ensure compatibility, it is crucial to make sure each one is plugged into the correct spot. These wires give the motors that are connected to the wheels instructions on what to do, as without these wires there is no way for the robot to move along with the other pieces, causing failure in movement. The infrared camera, which actually looks just like a pair of eyes, is mounted higher than the actual robot, as with this feature it is able to see objects from farther away, giving it an advantage on what to wonder with its next move. The camera is attached to a gear that helps it move in a 360-degree direction to make sure that the car is not backing or going up into anything. The infrared sensor is hooked up with LED and heat detection systems, but is only applicable when plugged into the Arduino board and the sensor shield. The camera is placed on top of the vehicle as it is easily noticeable from a faraway perspective. After listening to the main components of self-driving, it should be very clear as self-driving robots rely on a combination of components to operate autonomously. The Arduino control board serves as the central hub, connecting motors, sensors, and cameras. This intricate of hardware and software not only demonstrates the potential of robotics, but also lays the groundwork for transformative innovations in automation and AI-driven solutions, paving the way for a smarter and more connected future. This perspective on autonomous vehicles is how actual self-driving vehicles work, just with way more complexity and coding, as all these chips in this robot were integrated with code from the actual website. I want you to continue to follow this YouTube channel to expand your knowledge more, and I hope to see you in the future. Thank you.